Anyone?
X squared minus 2x plus 1.
Thank you very much. X squared minus 2x plus 1. Who was that?
Mickey?
Thank you, Mickey. Okay, so this equals the square root of, I have negative 3x squared and minus 2x and plus 5. Yay! I got a function. And what do I want? I want to minimize the distance. I got a function. That's all I cared about, really. So now I find d prime. Can anyone give us the derivative of this function? Anyone?
Is it going to be 1 over 2 square root, and then the inside of the function, times, and times negative 6x minus 2.
That's it. Very good. Awesome. What do we do now? So I can clean it up a little bit, factoring out negative 2. So I get 3x plus 1. And then 2 over the square root of 2 to the square root of negative 3x squared minus 2x plus 5. And these two will go away. So it's easier to determine when is d prime 0 at which x. Anyone? X equals?
Negative 1/3.
Negative 1/3. Coming back to my graph, obviously there will be 2 points. How do I know? In a moment we'll verify that. But I claim that this gives a minimum. Who cares what I claim? No one. I have to show why. So I have d prime of x and d of x. So I have at x equals, it's not possible. X cannot be more than negative 1 and positive 1. Lower than negative 1 and positive 1. Because we're talking about points between negative 1 and 1. There is no way. So we got negative 1/3, which is 0 here. And I'm looking at this function. I refuse to plug in anything in the denominator. But if I plug in 0 here, which is here, I get negative. And on this side, I get positive. You plug in negative 1, it's negative 2 times negative will be positive. So this is definitely a situation for a maximum. Oh. Oh, we're asked to find the maximum. Furthers the way. Furthers the way. Maximum, sorry. So it's definitely a situation for a typical maximum. Good. So I can determine it. I can plug in negative 1/3 in the original function. So do I want to calculate that by hand? No, I don't want to calculate that by hand. So I'm going to just calculate directly with the square root. And I have negative 3 multiplied by 1/3 squared. It doesn't matter if it's positive or negative because it's squared. But now I have plus 2 divided by 3 and then plus 5. Close the parenthesis. And I got 2.31 approximately. So 2.31 max distance. Okay. So now I have to find a point. We're gonna have 2 points, but I'm asked to find a point. So this is page 10. So I know that x equals negative 1/3. So now I have to find the y coordinate, knowing that x equals negative 1/3 squared, of course. So then y equals 4 minus 4 times 1 over 9. Okay. So then y will be 4 times negative 8 over 9. I factored 4 because it's easier for me. So 9 minus 1, so positive. So it was a y squared. That's why. Okay, so 4, so 9 minus 1 is 8. So I get that y squared equals 32 over 9. And now when I take the square root, I get plus or minus. So what do I get at the top? The denominator is 3, but the top is the square root of 16 times 2. So 4 the square root of 2. So then we have 2 points. Where is my graph? One point is here, and the other one is the corresponding point here. So point A and point B. Both have the same x coordinate, but one is the top, the positive 1, 4 the square root of 2 over 3, and the other one is the negative 4 the square root of 2 over 3. So the furthest away from point, I have to change this to C, sorry. I already named B. So the furthest away are point A and C, and they have the same x coordinate, which is negative 1/3, and the different y coordinate, of course, multiplicative inverse, opposites of each other. If this is 4 the square root of 2 over 3, this must be negative 4 the square root of 3. Interesting problem. Thank you for picking that. Good. We can continue forever with these problems, obviously. There are all sorts of different situations and different settings. What I would like to do, so we have all done, but it's up, I'm asking you to see what you're suggesting. I'd like to talk about Newton's method. Newton's method is fun. Newton's method is easy once you understand it, and we will be able to solve any equation that we were not able to solve before. Literally, any equation you want. Of course, among the ones that are not even possible algebraically. Is that okay if we look at the last section of this chapter?
Yeah, let's keep going. If we run out of time, we can always look at more next class.
This is the last topic for test 3. Newton's method.
What section was optimization?
4.7.
4.7, okay.
Yeah. 4.7. 4.7 is
the only portion of chapter 4 not covered on the test is going to be the 4.9.
4.9 and 4.6. So sections for test 3 are 4.1 through 4.5, 4.7 and 4.8. That's it.
Thank you.
Not 4.6 and not 4.9. So here is a function, and obviously it crosses the x-axis. So this is f of x. I want to be able to solve the equation f of x equals 0. So this is what I'm trying to do. We're going to call this r. R is the root, or r is the x-intercept, whatever you want to call it. We want to determine this, but we cannot do it algebraically. It's not a linear equation, it's not a quadratic, it's not a logarithmic or exponential, whatever it is, something that we cannot solve by hand. First step, I will identify a 1-unit interval. Find a 1-unit interval that contains a solution, a comma b, that contains r. How do I do that? For continuous functions, what was the theorem a long time ago that we looked at? What is it called? Any? Say it again.
Was it rolls?
No.
Was it the intermediate value theorem?
Intermediate value theorem for continuous functions that change sign. Excellent. So using the intermediate value theorem in step 1, we find a unit interval, blah, blah, blah. In step 2, so there are certain conditions, there are 2 conditions here. So I will explain the conditions at the end of the steps. Under 2 conditions that I will come back in a minute. In step 2, pick either A or B. What do you mean A or B? Yes, the interval. So I found the interval A comma B, 2 comma 3, a negative 2 comma negative 1, negative 1 comma 0, a unit, 1 unit interval, to either A, left end unit, or the right unit, end unit, to consider the first iteration. Let's say I pick A. X sub 0 is the initial value to find the next or the first iteration. So I pick. This is a pick. This is your choice. In step 3, I create a function and enter it in the graphing calculator. And now I will explain the method, and then I'll show the function. But first, let's talk about the method. Okay, so I'm just going to enlarge the situation here. So this is again R. And I'm going to say that I start, let's say, I start here. This is my B, and this is my A. I zoomed in. These are very close, 1 unit interval, but I zoomed in to explain what I'm doing. So this is my starting point. So this is my initial value. Here's what I want to do next. I will draw a vertical line, and I will determine this point. I'm going to call this point A. What are the coordinates of point A? Of course, this is our function f of x. Can anyone give us the coordinates of point A?
B comma f of B.
Excellent. Excellent. Thank you. Who said that?
Person.
Thank you. Perfect. We're just going to use x0, but it's perfect. A has coordinates b comma f of b. No question there. Good. At this point, I am going to draw a tangent to the graph at point A, extending it till it crosses the x-axis at point B. So this is the tangent. Can anyone give us the slope of this tangent? From what we studied so far in this class. Anyone? Oscar? Go ahead, Josh, go ahead.
F of lowercase b minus f of p over...
I want the slope of that line.
This is the rise of a run, right?
True. But that's algebra. what did we say in calculus?
The derivative of something.
Yes? I'm ready?
I haven't gotten that far yet.
Yes, you have. Oscar, what do you think?
The derivative of the f initial.
Yes. Awesome. It is f prime of x0. No question there. Good. So now Josh was ahead of us. He said that is the slope of this line between those 2 points. Correct. He is also correct. So I'm going to denote the coordinates of point B as x sub 1, comma, what? It's on the x-axis, comma what?
0.
Very good, awesome. So I hope you agree that this slope of AB is the same with, and now can anyone give us the slope of AB? We have 2 points now. Now we're talking about algebra. This one was calculus, but now I want algebra. So what is it?
A minus 0,
F of x0 minus,
0.
yes, f of x0 minus 0 over
X0.
minus minus x1 over x0 minus x1. Agreed? But this is the same with f prime of x0. Would you agree?
Yeah.
Okay. So we started with an initial value, our pick. Now, what do you think I'm going to solve this equation for? Before you answer, let me just give you a hint. This is my starting point. My initial value is this, which is, in my graph, this far away from the real solution. With this mechanism of determining a point and then a tangent, I determined the next iteration, which is definitely much closer to the real solution than my initial value was. Would you agree with that?
Yes.
So obviously what I'm after is x1. x1 is a better approximation of r than x0 was, or x0 was. Same thing. So I'm interested in solving this equation for x1. That's my target. So I will cross multiply. So I have f of x0 equals f prime of x0 times x0 minus x1. I will divide by f prime. So f of x0 over f prime of x0 equals x0 minus x1. And since I'm after x1, I will do this and write x1 equals x0 minus f of x0 over f prime of x0. So I started with an initial value and I got my first iteration. So this is first iteration. A better approximation of the real solution than my initial value was. Okay, stay with me because I want to show one more step. And I'm on page 12. So we did this. We started here, we got here. So this is my point B. Here's what I'm going to do next. Exactly what I just did. Create a point here now. draw a tangent line, determine another point that will have x sub 2 comma 0, which I hope you agree we were here with x0, we are here with x1 here, and now x2 is x2 a better approximation of r than x0, and of course I'm done with x0, than x1 was. And I continue the process till I get so close to this solution with 4 decimal digits, 5, 6, 8, 10 decimal digits, whatever you want. So can anyone without any calculations give us the formula for x2 and then for x3 and then for x sub n? Look, I'm ready.
X2 equals x1.
Exactly, minus f of x1 over f prime of x1. x3 will be x2 minus f of x2 over f prime of x2. Awesome. Who said that? Thank you. Of course, the last one will be, normally this one is denoted by n plus first, so we can have here xn minus f of xn over f prime of xn. This is Newton's method.
So does it really just like get a little closer each time? And
Exactly. Till you want to stop. Till you say, I'm done. I'm happy with 5 decimal digits approximation. I'm fine with 6 or 8 or 9. Yes.
Is there anything where you like use like a limit calculation to find what it's approaching? Or is it really just
no, it's not a limit situation. Basically, you could maybe find the limit of iterations, maybe, but no, because it's a ratio of values all the time. So coming back to my steps, knowing now what the process is doing, I'm creating a function and entering it in TI-84. What function am I going to enter? This is the function I'm going to enter, with, of course, without the suffix. Now, before we look at an example, I want to discuss this. Maybe they're not considered conditions, but they're considered warnings. Warning number 1. Make sure that f prime of x0 is not 0. So if I, by mistake, pick an x0 that has f prime 0, I'll never get anything. The method will never converge. So that's one warning. Careful. Do not pick x0 that creates this 0. Number 2, make sure that there is not a max-min between x0 and r. The method will never converge. It will never get closer and closer. It will always go further and further away.
So it's